Hi guys, welcome back to lesson 7.1, analyzing a quadratic function. And this is actually the first lesson of unit 2. So let's get started. You will definitely want your Springboard book. It starts on page 103. And then you'll want a pen or a pencil and your calculator. Okay, so applications of quadratic functions. So basically unit 2 is going to be all about quadratics, and those are like the U-shaped functions. If you see them on a graph, they're called parabolas. Okay, so unit 1 was all about linear functions, and now we are moving on to quadratic functions. Okay, so first thing here in our learning targets, we are going to formulate quadratic functions in a problem-solving situation. And then we are going to also graph and interpret quadratic functions. Cool. So starting up here, it says, Fence Me In is a business that specializes in building fenced enclosures. One client has purchased 100 feet of fencing and to enclose the largest possible rectangular area in her yard. All right, so number 1 says, if the width of the rectangular enclosure is 20 feet, what must be the length? Find the area of this rectangular enclosure. So real quick, let's just go ahead and talk about area and perimeter, because it might be a while since you've talked about that, right? So perimeter. Remember, that is adding up all of your sides, okay? So if we're talking about a rectangle here, that would be the length plus the length plus the width plus the width. Or you could say that as 2L plus 2W, okay? That's how you can find perimeter. Area of a rectangular enclosure is going to just be your length times your width. Okay, so that's just a little reminder. You might want to jot that down. Okay, so it says here, if the width of the rectangular enclosure is 20 feet, what must be the length? So in order to figure this out, if we know the width is 20 feet, we could do 2L plus 2W. And instead of your W, let's plug in the 20. And then it has to equal this 100 feet that he has total. All right, so 2 times 20 is 40. I would subtract that over, so you'd be left with 2L equals 60. So when you solve for that, you would get L, or your length, has to equal 30 feet. Okay. All right, now some of you could probably do that in your head, which is fine, okay? But then it also asked here, find the area of this rectangular enclosure. So area, again, is length times width. We now know the length is 30 and the width is 20. 30 times 20 is going to give you 600. And then just remember that when we're talking about area, we would measure that in feet squared. Okay, so now we've answered the 2 parts of number 1. Okay, all right, so now it says choose several values for the width of a rectangle with a perimeter of 100 feet. Determine what the corresponding length would be and the area of each rectangle. Okay, so what I want you guys to do is go ahead and fill out this table below, and you get to come up with whatever widths you want, and then you would come up with the corresponding lengths, and then you would multiply them for the area. So go ahead, pause the video, and do that now. And hopefully you guys came up with a bunch of different ones, but here are some options that you could have. A width of 1 foot and a length of 49 would give you an area of 49 feet squared. A width of 5 would give you a length of 45 feet and an area of 225 feet squared, and so on and so forth. So you could look through these and kind of check your work there. Okay. All right. And if you had some other ones, maybe you chose like 37 or something like that, you might have some different numbers. but these were just some basic examples, okay? So it says here in number 3, what is the relationship between the length and the width of a rectangle with a perimeter of 100 feet? So that's what you were doing in this last part. You had to each time be finding a length and a width that would give you a perimeter of 100 feet. But hopefully you're noticing the pattern here that means that the length and width have a sum of 50. Okay, so in each of these, you can tell 1 plus 49 is 50. 5 plus 45 is 50. 10 plus 40 is 50. 20 plus 30 is 50. Okay, so in each of these, whatever you chose as your width plus the corresponding length, it has to equal 50 in order to have that perimeter of 100 feet. Okay. All right, so then for number 4, it says, based on your observations, predict if it is possible for a rectangle with a perimeter of 100 feet to have each area. Explain your reasoning. So this is just a prediction. There really is no right or wrong answer. So I want you guys to, again, pause the video and go ahead and predict for parts, number 4, parts A, B, and C. Okay. All right, so hopefully you made your predictions. We'll refer back to those in just a little bit. Okay. Now, number 5 says, let L represent the length of a rectangle with a perimeter of 100 feet. Write an expression for the width of a rectangle in terms of L. Okay, so again, let's use what we kind of already know here, which was that 2L, and we did this on the other page, but 2L plus 2W equals the perimeter of 100. Okay, and because it says write an expression for the width, that means basically what you want to do is solve this for the width. So I would subtract over the 2L. And then to get W by itself, I would divide everything by 2. Again, to get W by itself, because that's what we're solving for. So we end up with W equals negative 2L divided by 2 is just going to be a negative L. And then 100 divided by 2 is going to be plus 50. Oops. Okay, so W equals negative L plus 50. Or if you had 50 minus L, that would be fine also. Okay. Then in this next part, 6, it says express the area A of L for a function with a perimeter of 100 feet as a function of its length. Okay, so now we know, remember area is your length times your width. So now we know area, or A of L, equals length times width. But instead of width, what I now want to plug in is this right here so that we're doing it all in one variable. So we know that width is equal to negative L plus 50. So what I'm going to do is erase the W. Whoops. And instead, I'm going to plug in that negative L plus 50. Okay, and then obviously I would simplify here. So that's going to be A of L equals a negative L squared plus 50L. Okay, and that's super important. That's what we're going to be using as we move forward here. That is our quadratic function. Okay, because it has that squared, that's what makes it our quadratic function. Okay, so this next part is asking you to graph it. And what I would do is maybe make a table. And L is like your x-axis, and area, A of L, is like your y-axis, right? So I would plug in a few terms or a few points. So maybe you want to plug in like 0, 10, 20, 30, 40, 50, just because those are the kind of tick marks on the L axis. And when you do that, if you plug in 0 here, you're going to get negative 0 squared plus 50 times 0, which is 0. Negative 10 squared is 100, plus 50 times 100 is going to be, that'll give you 400. If you plug in 20, you're going to get 600. If you plug in 30, you're going to get 625. If you plug in 40, you're going to get 600. And if you plug in 50, if you plug in, not 600. Oh, yikes. Hang on. Made a mistake there. This is also going to be 600. Then this is 400. Then this is back down to 0. Okay, so it's kind of a pattern there. And like I said in the beginning, that quadratics are this U shape. So this is what your final function should look like. Okay, noticing that we have the point 0, 0. We have the point 10, 400, 20, 600. Whoops. 30, 600, 40, 400, and 50, 0. Okay, cool. Then number 8 says, now using a graphing calculator to graph the quadratic function, set your window so that it matches this. You guys could try that on your own. Okay, try graphing it in your graphing calculator. And then number 9 says, use the function that we just came up with up here, A of L equals negative L squared plus 50L. And it says, what is a reasonable domain of the function in this situation? Okay, so we know that the domain technically would continue on in both directions here. But when we're talking about a reasonable domain, we're talking about in the context of this situation. So we only want to really talk about a length that makes sense. So that's going to be from 0 to 50. Okay, so a length of 0, we have this point here, and 50, we have this point here. And now what's funny is we actually don't want to include either of those because, so we could write it like this with parentheses, or we could write it like this without the equals underneath. But we don't want to include those because both of those lengths would yield us an area of 0 feet squared. Do you really want a fence to enclose 0 feet squared? No. So that's why we're not going to include those. Okay. So that's how we would write our domain. And then part B says, over what interval of the domain is the value of the function increasing, and over what interval of the domain is it decreasing? So if we look here back to our graph, we would say that it's increasing all the way till it gets to this point, our maximum point, and then it's decreasing all the way down this way. Okay, so how we're going to write that on the next page is increasing would look like from 0 to 25, and we're going to include the 25. And then decreasing would look like from 25 to 50. Okay. And that's just as we work up the U shape or the parabola, that's where it's increasing. As we work down, that's where it's decreasing. Okay. Then what is the maximum? That's what I was just talking about. Okay, so that's going to be this point here that I mentioned. That's your maximum. So that looks like it's at 25 on the length and about 625. And if we actually plug 25 into our equation, we would know that that's what you do get out for the area. So we want to say that the maximum rectangular area, the maximum area is 625 feet squared. Okay. All right, the next part, it's talking about what is a reasonable range. And that is going to be from 0, because again, remember the range of the y values is talking about your area, and we don't want to include that area of 0. But we do want to include the maximum area that we just came up with, which is 625. Awesome. All right, so explain how your answer to item 10 helped. Well, again, we just used the maximum to be the ending function of our range. Okay. And then last part we're going to talk about here is go back and look at your predictions and see were you right or wrong. Could we have a 400 feet squared fence area? Yes. Could we have a 500 foot squared? Yes. Could we have a 700? No, we know the maximum is 625. Okay. Alrighty, so that is it for this video. We will talk more about this example and word problems like this during our Zoom tomorrow. Have a good one. Bye-bye.